Welcome to E-Pathashala Architecture lecture series for MArch students. As part of the sustainable and green building design, today we will be discussing about GRIHA. GRIHA means Green Rating for Integrated Habitat Assessment. Now, there are various rating systems for rating buildings as green depending upon the greenness of the building. For example, UK follows BREEAM, which is Building Research Establishment's Environmental Assessment Method. Japan follows CASB, Australia follows Green Star, and Germany has Passive House. Some of the European countries also follow Passive House. In this context, India also needs a rating system of its own, and that is where GRIHA comes in. GRIHA means Green Rating for Integrated Habitat Assessment. There is also LEED India, which can be used as a green building rating system in the Indian context. But today we will be looking at GRIHA and its salient features. GRIHA has been developed by TERI, the Energy Research Institute, New Delhi, and developed jointly with the Ministry of New and Renewable Energy, Government of India. It is a green building design evaluation system, which means based on its evaluating system, we can assess a building for its greenness or sustainability. And it is important to understand that it is suitable for all kinds of buildings, residential to industrial, all kinds of buildings, and for the various climate zones of our country. The organization of green rating system by GRIHA has these following things to be considered. First is site planning, building envelope design, which means how the outer part of the building is designed, building system design, which means the services for a building like HVAC system, lighting, electrical, water heating, integration of renewable energy sources to generate energy on site, water and waste management, selection of ecologically sustainable materials. With high recycled content is a better material compared to new materials, rapidly renewable resources with low emission potential, etc. Indoor environmental quality, it maintains the indoor thermal temp as well as air quality inside, which is called as IAQ, indoor air quality. Now, why do we need GRIHA? The agenda of GRIHA is like this. Any building is going to consume a lot of resource in the form of energy, water, materials, and even human resource. Normally, we do not include human resource because it also means a way of making people get some kind of a remuneration or livelihood. So, human resource is normally not considered. But when we consider consumption of resources like energy, water or materials, we have to be very prudent considering that these three things can aid in global warming. Also, we emit waste directly in the form of municipal solid waste or liquid waste as well as emission of green gases. So, the agenda of GRIHA is to reduce or minimize buildings resource consumption, minimize waste generation, and hence overall ecological impact to within certain nationally acceptable limits or benchmarks. The primary objective of the rating system is to help design green buildings and in turn help evaluate the greenness of the buildings. How does GRIHA give certification for greenness? It gives on the basis of stars. If a building scores between 50 to 60 points, the building gets 1 star. If a building gets 61 to 70 points, it gets 2 star. If it gets 71 to 80 points, it gets a 3 star. 81 to 90, 4 star. and 91 to 100 is 5-star, which means a building which is 5-star is the greenest building compared to the other buildings. Compared to 1-star, 2-star is a much greener building. There are these important criteria that has to be followed for getting our buildings evaluated for greenness or in GRIHA. Criteria 1 is site selection, criteria 2 is preserve and protect landscape during construction or compensatory depository forestation. Criteria 3 is soil conservation including post construction. Criteria 4 is designed to include existing site features. Criteria 5 is reduce hard paving on site. Criteria 6 is enhance outdoor lighting system efficiency. Criterion 7 is plan utilities efficiently and optimize on-site circulation efficiency. Criteria 8 is provide minimum level of sanitation or safety facilities for construction workers. Criterion 9 is reduce air pollution during construction. Criterion 10 is reduce landscape water demand on site. Criterion 11 is reduce building water use or consumption. Criterion 12 is efficient water use during construction. Criterion 13 is optimize building design to reduce conventional energy demand. Criterion 14 is optimize energy performance of building within specified comfort limits. Criterion 15 is utilization of fly ash or equivalent industrial or agriculture waste as recommended by BIS in building structures. Criterion 16 is reduced embodied energy of construction. It is reduced by adopting material efficient technologies and or low energy materials. Criterion 17 is use low energy materials in interiors. Criterion 18 is renewable energy utilization. Criterion 19 is renewable energy based hot water system. Criterion 20 is waste water treatment. Criterion 21 is water recycle and reuse including rainwater. Criterion 22 is reduction in waste during construction. Criterion 23 is efficient waste segregation. Criterion 24 is storage and disposal of waste. Criterion 25 is resource recovery from waste. Criterion 26 is use of low VOC paints or adhesives or sealants. Criterion 27 is minimize ozone depleting substances. Criterion 28 is ensure water quality. Criterion 29 is acceptable outdoor and indoor noise levels. Criterion 30 is tobacco and smoke control. Criterion 31 is provide at least the minimum level of accessibility for persons with disabilities. Criterion 32 is energy audit and validation. Criterion 33 is operation and maintenance. Criterion 34 goes to innovation points. What does this mean? It means that any building will be evaluated at least on the basis of these 34 criterion to get points and therefore be eligible for the appropriate star rating system, which means these may not be exhaustive. An architect or a designer can include many more aspects of sustainability or greenness in his design, but he definitely has to address at least these 34 criterion or points. Compliances as specified in the relevant criterion have to be submitted. The intent of some of the criteria is self-validating in nature, but for some of the criterion such as energy consumption, thermal comfort, visual comfort, noise control and indoor pollution levels, it cannot be validated on site through performance monitoring. The points related to these criteria are avoided provisionally, that is based on whatever is committed by the client, it is awarded while certifying and then later converted into firm points through monitoring, validation and documents or photographs to support the award of point, which means even though it may be committed, the building is going to be thermally comfortable inside. The points awarded are only provisional. Only after the occupants enter the building and then through appropriate monitoring system, this is validated and the
Many
points
of the
are
criteria
made
for
firm,
granted.
which means you cannot take many of the criteria for granted unless you prove it correctly or completely. Now, we will start looking at each criterion individually. The first criterion we will discuss now is site selection and site planning. Under this, we will look at conservation and efficient utilization of resource. If you look at resources on site, they are mainly land, water, vegetation. Vegetation meaning the natural habitat for flora, fauna and the other things on the site. The objective of this criterion is to maximize the conservation and utilization of resources like land, water, natural habitat, fauna and energy conservation, and enhance efficiency of the systems and operations. What all aspects must be included when we look at site selection? It is the first step to a sustainable habitat and needs to be done appropriately prior to commencement of design phase itself. Site selection and analysis should be carried out to create living spaces that are in harmony with the local environment, meaning to say, irrespective of however efficient the design may be, it should not be an eyesore from the outside in a given local environment. The development of a project should not cause damage to the natural surroundings of the site, but in fact should try to improve it by restoring its balance. So, a designer or an architect has to understand the natural surroundings of the site, and then his design should aid in restoring the balance rather than creating any kind of damage. The reason being, it takes millions of years for any natural formation to happen on site. A crude decision by the architect should not be so bad that it destroys millions of years of work done by nature. Thus, site selection should be carried out in the light of a holistic perspective of land use, development intensity, social well-being and preservation of the environment. Now, we look at some of the case studies where, what I mean to say, these studies have never gone for GRIHA to get their rating, but we can clearly see the kind of buildings that have come up in this setup. The buildings are completely gel with the surroundings, with the greenery. They are not an eyesore for so many reasons. For the way the skyline has been done, for the way the building materials have been used. So, when we look at sites which are sensitive, an architect needs to be extra careful in the way he designs on those sites. The second criterion is to preserve and protect the landscape during construction and giving compensatory depository forestation. It means to preserve the existing landscape and protecting it from degradation during the process of construction. What are the ways in which damage can happen to an existing site? The first and foremost damage that can happen is by removal of trees, which means when we design, we have to be careful to minimize removal of any trees, because when a tree is removed, it is not just an individual tree that is removed, but an ecological system that may get removed or that may get affected. The tree may be hosting lots of birds, it may be hosting butterfly, it may be hosting bees. Removal of tree is not a simple act, but it could lead to destruction of a small micro habitat within the site. The second way in which damage could be caused is because of the way we do our foundation. So, what happens when we do our foundation? We are actually removing topsoil. Topsoil is very, very fertile. It is one of the most fertile soils. What happens? So, When you remove topsoil and dump it elsewhere, you have removed fertile soil. These are the things which should be avoided. So, it involves proper timing of construction, which means we should not start our construction during heavy rains. It causes erosion and therefore, the topsoil cannot be preserved at the time of construction. Next is preserved topsoil and existing vegetation. So, topsoil is preserved by taking the soil and keeping it separately. After the building construction is over, the topsoil is again laid back around the building on which we can plant our trees or lawn or any kind of vegetation. Staging and spill prevention to prevent spilling contaminated material on site. For example, if there is a need to run a motor or a generator, we should ensure we do not spill any oil or anything which is toxic to the soil. Erosion and sedimentation control, which can happen. We can prevent erosion and sedimentation by choosing the appropriate time of building construction as well as taking some other measures. Replant the trees that were cut down during construction in the ratio of 1:3. For the first, let us design in such a way that no tree is cut, which means the design itself gets integrated within the existing landscape. If at all for certain reasons a tree needs to be cut, then we need to replant it at the ratio of 1:3. For every one tree removed, we need to plant 3 trees. This is a small example at Y3 resorts in Wayanad. Again, it is not a green rated building, but you can clearly see how they have integrated the landscape within the building, or rather the building just forms part of the landscape, does not look an eyesore, gets integrated with existing flora fauna apart from a lot of flora and fauna that is added to this building. Criterion 3 is soil conservation till post construction. Conserve topsoil till after completion of construction activity. This commitment entails proper topsoil laying and stabilization of the soil to prevent erosion and maintenance of adequate fertility of the soil to support vegetative growth, which means we have already seen this topsoil which is full of humus from the falling leaves and therefore has lot of organic growth in it, which is not possible in soil which is much below the earth. When we dig this soil for our foundation, the soil must be kept separately, and then after the building activity is done, this soil must be laid back on which we can grow our lawns and vegetation. This time I am going to show you an antithesis. This is one building in a developed country. You can see how a green place, which is on the top corner, green place through an architectural intervention is converted completely barren, on which artificial lawn and plants are placed. What I mean to say is, there was a beautiful natural landscape, the entire landscape was removed, building construction activity done, to which few plants and little bit of grass has been added. It is an antithesis and must never be done. Criteria 4 is designed to include existing site features. A site in general will have its own features, like probably a water body, if not a water body, at least contours. When we have contours, it means there is a direction in which water could flow during rainy season. There may be other things like small boulders, vegetation, some plants, some shrubs. The natural functions of a plot of land has hydrologic, geologic and microclimate. It can be disturbed by the placement of a building on it. We need to design green buildings which will factor in ways in which the natural site features can be protected or even restored. Lay out the site activities and building requirements after carrying out detailed site analysis, so as to ensure sustainable site development in tune with its topographical, climatic and ecological character. If there is a contour on the site, we need to respect the contour and use it as an existing feature. This is an example of Johnson Diversey headquarters. There was a swamp behind the site. The architect or the designer had a choice of completely closing this swamp and then building a massive structure on it. Rather, he chose to design in such a way the existing swamp is protected and then it is further restored by making it into a larger swamp. Criteria 5 is reduce hard paving on site and or provide shaded hard paved surfaces. Reduce hard paving on site in open areas around the building premise to minimize the imperviousness of the site. If a site becomes impervious, rainwater is not going to seep in, which means the ability to recharge our aquifer will get reduced. Provide shade on hard paved surfaces to minimize the heat island effect on site. If we are going to provide, if at all we are going to provide hard paved surfaces, we should ensure that the hard paved surfaces are protected from the vagaries of sun. Otherwise, it is capable of absorbing heat, it meaning the paving is capable of absorbing heat, reflecting or radiating back the heat. If in a particular area there are too many hard paved surfaces, then you can clearly notice the heat island effect, because the temperature of the place will be slightly higher, the microclimate will be slightly harsher or higher in that particular place. To prevent that, we must avoid hard paving on site surface, or at least we should shade it. I am just showing a couple of examples of how it can be done. So, there is another way in which we can do. We can have roof gardens also. Roof gardens will minimize heat island effect. So, there are these two buildings where I have given an example. In the first building, the roof is treated as a separate entity and it is made green with landscaping. In the second one, the entire building is stepped or like a terrace and has greenery throughout, which means we do not know where is the terrace, where is the envelope. The entire building is covered in greenery. Naturally, it is going to reflect very less heat. It is also going to absorb very less heat, as the vegetation acts like a cushion or a buffer. Another example of roof garden which minimizes heat island effect. It also provides psychologically comforting environment to the occupants. Enhance outdoor lighting system efficiency. It means that it is important for us to consider outdoor lighting, one, which means our site cannot be unsafe by making it dark. Second is, we also have to ensure that the lighting system is efficient, it is energy conserving. Enhance energy efficiency of outdoor lighting and promote usage of renewable forms of energy to reduce the use of conventional or fossil fuel based energy resources. If at all you have to have too much of lighting on site outside the building, we must restore to renewable forms of energy like solar energy. Meet minimum allowable luminous efficacy as per lamp type and make progressive use of a renewable energy based lighting system, which means all our lighting system must be such that it provides enough light. The issue is that it cannot be designed separately because there is a lot of vegetation. When there is vegetation, there are chances of lighting being cut. So, designer has to be prudent in understanding the lighting of a particular place along with the existing vegetation. Criterion 7 is plan utilities efficiently and optimize on-site circulation efficiency. So, it is not sufficient that we design only the buildings and the site around the buildings. with greenery, we also have to consider how people are going to move around on the site. So, reduce site disruption due to laying, maintain utility lines and minimize energy use by on-site utilities. To reduce transportation corridors on site, thus reducing the pollution loads. One way in which this is happening now is, and people are also quite accepting to the idea of pedestrianizing campuses or pedestrianizing their sites, which means how this can be done. How can we make a site pedestrian friendly? One is by ensuring you design the pathways in a very interesting manner so that people are encouraged to walk. Second is we can use bicycles. Bicycles are a very green way of transportation. So, the entire system can be worked out in such a way that bicycles are provided for people to move from one point to another within the site. We also have to consider barrier free environment for the physically challenged, the elderly people or people who carry small children or people who carry a lot of luggage. For those people we can consider battery operated vehicles. Also another operation, another way in which this can be operated is we can look at carpooling. So, with this we can see what are the ways in which we can treat our site. You can see that we can treat our site first by appropriate site selection. So, the site that you select must be very appropriate for that particular activity in such a way it does not bring in too much of traffic. For example, if it is a residential area, we should not choose a site where there is going to be heavy vehicular traffic within a residential area. So, it is in the hands of an architect to advise this to his clients. What are the other ways in which we can gain some points in this criteria? Because for every criteria marks are allotted by GRIHA. If we are able to select a brown field, so brown field is a site which is dumped with a lot of toxic waste. Toxic waste can come in many ways. It could have been an old hospital site, or it could have been a site where an industry would have been there, or it could have been a site where industrial waste might have been dumped, or it could have been a city dump yard. If we select challenging sites like these and an architect tries to design on it, the architect is capable of getting the building get more marks in the criteria of site selection and site planning. So, with this module we complete site selection and site module. Thank you.